Okay, thank you, Philip. So I'm Alexandros Nizamis from Center of Research and Technology, ELAS, and National and Kapodistrian University of Athens. And I'm going to present our work regarding the introduction of enhanced metadata broker for manufacturing data spaces. As Philippe said, it's something in the middle with architecture of data spaces and also with some kind of use cases. It's targeting on the manufacturing ones. So we're gonna see which is the problem that we are facing and why we need to try this kind of implementation. After that, some core parts of this implementation. Also, I think now the presentations will start to become a bit more technical, maybe in this section as we're talking about use cases and so on. And we will see some core parts of this metadata broker that we have introduced based on the paradigm of available solutions, of course, and some short discussion on it. So first of all, regarding the problem is to see how we can further support the collaboration on data spaces. So far, we have a lot of applications and implementations regarding the data connector. So you can try to push or retrieve data by following this concept of data providers and data consumers with the data space connectors in the middle. But the case is what is happening with metadata and also how discoverable are the data. We have also these kind of FAIR principles and EU AI Act and Data Act as well. Now we see that there is a lot of effort for some common European data spaces, so it's very important not only to find data, but to be able to discover this data and be sure that you can use this data, if this data makes sense for you. If we imagine that in 10 years from now, maybe we will have some fully operational data spaces with thousands of nodes, we will have a lot of data. So we will be able to search and see which data maybe is capable for me to use them, not to try all. So this is, we're going in our approach for the manufacturing domain that there is some expertise from the authors on it. And we are based on implementations coming from IDSA broker and also GaiaX catalog, etc. And our approach is to enrich this broker by adding some ontology on the back end for describing in a common way the data sets that are related to this kind of data space. So to provide some help to data scientists that want to implement some solutions to analyze and implement some solutions regarding this data set. So the first step is to set up our data space metadata registry ontology. For now, what we have in manufacturing domains were some ontologies that are related to manufacturing processes, not on actual data. And also we have some more generic approaches regarding data mining ontologies as well. So we try to combine a bit these ontologies and borrow some concepts around and there and following a methodology to build this first version of our ontology. Now it includes 59 classes and 14 objects and of course object properties and data properties as well. And what we try to do is to connect metadata related to a data space broker and, as I said, also metadata connected to a dataset that should be described through this broker. Here is a diagram how this ontology looks like, and also we have some descriptions of our classes that we have set up. So we keep some common information regarding the metadata broker that exists also in IDSA reference implementations with the self-descriptions about the broker. And we add as a core part the dataset, as you can see. So now a scientist or a developer could find in an easy way some information about if the dataset is something about big data or not, some quality procedures, which is the usage of this dataset. So we add some core manufacturing domain here type of usage. For example, if it is used for predictive maintenance, for production scheduling or whatever. Of course, some other information about the data characteristics, the owner, etc., etc. And we have built a full semantic framework in the back end of it. So we need a way this ontology to be available for providing the CRUD operations by developers and researchers. So everything is available through REST calls in order to get this kind of information of a dataset. So everything that is described with this ontology is able for someone to get it by using the REST protocol, and also we have GraphDB as a backend in order to use it as a triple store for storing all this kind of data, so it can be used for other kind of applications as well if any metadata search is needed. It is based on Python implementation, of course, the backend, and we're using microservices logic for deployment in order to support the concept of the architecture of the metadata broker. So we have keep the common parts based on IDSA implementation, that we have configuration manager, execution core container, etc. And what we add new here is some containers related to the core backend, which is a semantic framework that I have just described, starting from ontological resources in GraphDB, an ontology handler, and also the REST API at the top of it. And also we introduce a user interface about that. It's something that's still under development, and to see how a user can embed and add info in this ontology and the triple store in the backend to be associated with the data that should be transmitted through a data space connector. So this is how it looks like. We're facing the IDSA reference architecture model specifications and description about this kind of dataset, that this kind of interface. So a broker should be a kind of website or web interface in general that can provide some search capabilities with some drop-down menus, and also to be able to embed some full text on descriptions and so on. And also we check further applications regarding some AI models marketplaces, because there we find some interesting approaches about describing datasets. So you need, if you want to adapt an AI model used somewhere else, you should be also able to see some metadata regarding the dataset that this model is trained. So this applies a lot to our case here. So you can add all this info for your dataset and translate it by using our framework to actual ontology instances and stored in the GraphDB. So you can select, for example, here the data usage, if it's for a robot application, for defect detection, as I said, which is the data source, and so on, or other kind of drop-down menus. And also we have option other if you want to add some free text and create the relevant instance. As I said, this is not fully implemented yet, and will be also part of our next steps. So we consider as main contributions here that we did a kind of discussion about some specific issues related to metadata for Industry 4 and 5 in manufacturing domain. Of course, we have implemented this data space metadata broker for this domain. So we have the core part, which is the backend that is operational, and we're trying to fully extend it in current period. We have created this initial version of semantic framework to run on the top of the ontology and the user interface. So our next step is to further implement what we have done, and to add more services based on SPARQL queries, and try to get more information regarding a dataset that is described in a connector and is connected in a broker. And of course, to test it in some to test the full implementation in some manufacturing data spaces. Now there are these new projects such as Maintenance and Underpin, which is trying to deploy manufacturing data spaces now in Europe, common manufacturing data spaces. And we would like to experiment and see in some cases there how this work could look like. I think that's it for me. Thank you.
You follow the approach of the UI, but do you also invest time in like automate things? Like, because I think the best UI is no UI here.
Yes, it's about this. All the UI is using an API in the backend. It's something that can be used also for make it automatic. So when you set up maybe a broker or connector, you can use this this API at the backend. So the UI is just call this API. I think our core contribution is this kind of API with services that you can call it also in other backends if you wish.
And machine sensors would be automatically call this API.
Yeah.
So
they can get them, yes. Not to search through the UI. So but the idea is also to add the UI because we need some kind of maybe the data provider to be able to push the data, not to use any developer or something if you in a data space.
If you go into industry, like then you have like a manufacturing like Siemens or Bosch or so. I think
Yes,
they need to
this
integrate
large
this in their machines and then automatically.
Yeah, this will do it automatically through the app for sure.
You had this attribute of data quality procedures, and how this works. So I as a data owner do some data quality methods on this, and then I
just to add what data quality procedures maybe you have already applied on this dataset before you publish it.
Detections and so on. And
this detection, etc., I think is in the part of application, not in the quality. We have just if you did any kind of pre-processing with some specific classes to describe it.
Okay.
I think.
No more questions? Thank you so much, Alexander.